Ready, set, go. Woo! Okay, hello everyone. Today I'm gonna take you on a journey about the new ReasonReact. Is this better? Okay, journey about ReasonReact. Who am I? As Jared already mentioned, I'm Nick Graf. I do consulting and freelancing, and I work a lot with GraphQL, TypeScript, Flow, React, whatnot, but I really like to explore. And for me, the journey with Reason started about like 2.5, 3 years ago, because I really liked what I saw there, what was possible. And 2 years ago, then a friend of mine asked me to like, hey, what about we organize meetups since 4 years? Should we do a conference? Yes, and that's what we did 1 year ago. Organized the world first ReasonConf, and this year, a month ago, we did it as well. And for that, we also started the Reasoner Association, basically a project where we collect funds to reinvest it into the Reason ecosystem. But what's Reason? Or especially before we talk about ReasonReact, we first have to talk about like quick overview, what's Reason and what it does and what it doesn't do. To me, I would describe it as like a practical, type-safe, functional programming language. And I'm going to teach you a programming language now. Next slide is really fits. Don't panic.
No problem.
All right. Now it's my hair. Yeah.
Yes. Okay. Thank you.
This one. Okay. All right. So even we're learning a new language now and having slight problems, don't panic. It's going to be fine, because mostly a Reason is like it has a JavaScript developer-friendly syntax. That was one goal, to make it really, really nice for web developers. And I want to show you some quick examples, like this one, for example. The meaning of life is 41 plus 1 is 42. That's pretty straightforward. It's a valid Reason as well as a valid JavaScript syntax statement. We can have arrow functions. We can define a list. We can have an if condition. That said, it's not always the same, and there will be some weird syntax, but don't worry about it. You can skip over it, because the things that I really care about, I want to teach you today or mention, I will explain them anyway. But that said, it has this OCaml semantics, and it compiles then to JavaScript. And I want to make one thing clear before we actually get right into it. My goal is not to convert you to Reason today. My goal is not that you go back on Monday and actually use it, but what I want to do is I want to inspire you and give you ideas of like how developer experience can be better and where we actually could go or want to go. You might ask yourself like, but when should I use Reason? And for me, the story is always like when you're ready. Basically, when your team and you are ready, and that means like if you basically at the point where you're frustrated with TypeScript or Flow and you feel like there could be something better, then you might jump on it. But if you have a team of like that is just getting used to typings or even not there at all, it might be that the trade-offs might not be the right ones to jump right away on it. And but I want to inspire you. Let's get back to that story. So, and we might already have, because who of you uses or knows Prettier? Raise your hand. Okay, almost everyone. And you know, the thing, Prettier was actually inspired by Reason, by the reformer tool that predates Prettier. James Long, when he tried out Reason 2016, he got very much inspired by the experience of like that everything formats correctly and there's exactly one way of doing it. And that's how he wrote. That's why he wrote Prettier when he went back to JavaScript, because he couldn't stand the experience of like just linting anymore. And that's how it happened. Okay. So now that was history. Let's actually show something cool. Show something that might inspire you to build better tools. And I know I'm taking a big leap here, but we basically want to build, I mean, the application is not particularly cool in itself, but we want to build a small application that fetches with Apollo data from an endpoint. So there's a GraphQL endpoint, and you can basically pass in a query, and then you can fetch data, you get back JSON. And here I'm going to show you Reason code. What's happening here is at the top, we basically have a GraphQL query that we can write. And the really, really cool thing about this is if we do one introspection query and like save the schema locally, what we can do with Reason is we can give you type safety even on the query. So if you have something, if you have like, if something is not part of the schema, it will tell you. If you do a typo on population, it will actually let you know, hey, this doesn't exist. And you can't make mistakes in that case. Because only what's available here is actually what you can get. And it gets even better when you go down, further down to the part where you actually access the planets that we are fetching here, is it will tell you if something, for example, if you try to fetch a description, but you didn't try to get it in the query, and it doesn't exist there, then it will not match up, and you get type safety there that it's not available. And basically, when you add a field to the query, then it becomes available further down the road. Cool, but we can do this in TypeScript. Can we? Yes, that's right. That said, the experience is a little bit different, because in Reason, it all happens magically, and it does it for you. And the experience in TypeScript is different, because what you need to do is, first you need to run a CLI to actually generate the types. I mean, to be fair, we also needed to do one introspection query to like actually get the data structure. But here you need to run a CLI that actually checks your code, particularly this gets planets query, checks your code if this is available, generates types based on that, and once that's done, is the generated types you then can import, and then you have to annotate it. And these are like a lot of steps to actually get auto-completion and to get type safety into your code. And it's doable, but what I see in my day-to-day when helping teams onboarding to GraphQL and so on, I see they struggle to actually use this because it's so many steps all the time that they simply don't do it, some of them. And then you have inconsistencies and you have discussions, and it leads to basically not the best experience and not the type safety that we're aiming for. Cool. And one more thing, especially in these cases, once you start doing that, because you're generating the types based on your code, it basically runs through all your files and inspecting them in TypeScript. You have to have the queries, the query names, this get planets, here right below get planets query, has to be like globally unique in your entire code base, because the generated types will be different then. And so how can we do this in Reason? What we do here is we use something called PPX, which is a code extension. So basically, what you see here at the top, this weird thing with like the brackets opening and then GraphQL, it's basically something like it's custom syntax that we can hook into in our compiler and extend it and tell it like someone wrote code to actually make GraphQL a thing that generates an actual module. And this module not only like gives you all the useful things like how you query the actual data and how you can construct the query and so on, it also gives you the actual types. And basically, when you then run the query, the types are also in there. And this is why when you look at this file as a total, there's not one single type definition, but everything is generated and you're like still 100% type safe. And this is basically, this is the experience that I'm looking for, like write less, but get the same kind of safety. Cool. So now that I showed you that part, and I know this was a big leap, let's actually take a step back and talk about ReasonReact and how we can get started and start from the beginning. Especially since we've seen a PPX already, ReasonReact, the new version, also is based on, or like it requires, doesn't require, but like it gets a lot more handier if you use this PPX. The React component PPX. And what you then do and have is, so this is a simple hello world example where you get one property name and you say hello and then whatever comes out. And what you can see here is, in the end, then it's just a function that you basically assign to a variable, or we call it, you bind it to a name make in this case. Then these are the parameters, the props. It looks a bit different. I will explain that in a second. And then you have the JSX that is returned. Obviously, you could use curly braces, and you can do more stuff in the render, but that's not the main point here. You have the function body. And then you can render it to your ID root, the div, and you basically have JSX. So JSX is also part of the whole story, and it's built in. All right, as you can see here. And then the outcome is simply an H1 with Hello Paris. What does this compile to? Well, that's why we need the PPX, or why we want to get from this one weird syntax to actually, we need it because we want to get something that almost looks like you would have handwritten it. So the output of this here, this here, actually leads to this here. This is just a function. It receives props. You extract the name, and then you do react.createElement. Basically, what JSX does, if you have an H1 tag, this is exactly the code that Babel generates for you. If you have JSX, this is what Babel converts it to. So there were 3 things that might be really, really odd for you if you see this the very first time. Let's go through them right away. Why is there a react.string? Maybe you have missed it, but here it is. This is kind of weird. And this has to do with polymorphism. What's polymorphism? Basically, polymorphism means if one variable can have like very different types, or if a function accepts, if you have a parameter, it accepts all sorts of types for this. It accepts like, for example, a string or a number and so on and so forth. And this is exactly what in JavaScript React leverages. What you can provide as children of a component can be various things. It can be another React element, because if you use a component or if you have an HTML tag, that is like in JSX, that compiles to or like it creates a React element, but also React accepts strings and numbers and booleans and null and arrays of strings and whatnot. But Reason is different, because Reason and OCaml, it's not polymorph. So what this means is every time you accept a parameter, it can only be of one kind of type. There are ways to define this, how to accept different things, but then this would be kind of cumbersome for JSX. So we basically, to fulfill the type system, and this is definitely a downside. Personally, I find this really, really annoying, but this is a trade-off. But what we can define is react.string. We can kind of tell the compiler, hey, if you get a string, return me a React element. And this is then the type signature, and since we know under the hood React accepts strings, this is fine. We don't even have to generate any custom code with it. We just have to tell the type system, hey, this is actually okay. So, second thing that might be really, really odd to you are these props. They are actually labeled parameters. You have seen the tilde before, and for that, to explain this a bit further, I wanna show you a bit more complex example already, where you see you have here the name, you have actually 3 props: a name, characteristics, and population. The name is a string, population is an integer, characteristics is an array of string. And then we can show the name, we can map over the characteristics and show them as well. And for the population, we can also render it. And then you can use it again. So let's say we have the species Vogon, and their characteristics are bad-tempered, bureaucratic, and callous. But there's a pretty large population. So again, pretty straightforward JSX. One thing though is what's happening here is like why, or like to be more specific, like basically instead of like accepting one object, ReasonReact is designed in a way that it accepts multiple named labeled arguments. Labeled named is basically the same meaning, but what it does is I can provide them in any order if I name them, and it doesn't matter. You have this in Python, you have this in other languages. We don't have this in JavaScript. That's why we kind of do a workaround where we basically accept an object and then you kind of emulate this behavior. But in a lot of languages, this is native to the language, and then you can use this. And because of this PPX, of this code manipulation, React.component, it does exactly what you have seen before. Props, actually, when you compile it to JavaScript, becomes an object. So our named parameters here, in the end, like if you compile it to JavaScript, are an object that you can simply destructure and so on and so forth. So why not use an object in Reason per se? Well, there's one thing again here, and this has to do with type inference again. The idea of like, if you look at this file, there's not one type definition. But because we have this, because Reason and OCaml doesn't allow for polymorphism, the type checker can actually be way, way smarter, or like it feels like it's smarter, because it's way, way easier and quicker to determine, just based on the code, what the property, what the type must be. So if you look at name, basically the type checker can figure out there's a React.string function. That means name can only be a name, so you don't even have to write name : string, because the compiler already can figure out like, hey, I know like this only can be a string, so it must be a string. And if a type, if something can only be of like one type all the time, is actually, it's still a hard thing to do, but it's Reason and OCaml, they can do it. They can figure out the type based on just how you use it. And this means like you have to do a lot less type definitions. And same for characteristics, because what's happening here is belt.array.map is actually, it's accepting array of something, and then inside what you do with it is you use React.string on it. It can figure out by itself characteristics must be an array of string. It can't be in any other way different than that. If not, you have a major problem. And the same for population, because we use string of int, we convert it to a string, and then it's a string. It basically, like, it can follow the code and figure out like how to convert it. And that's one thing that is really, really nice. And this is exactly, if you think back about our previous example with fetching from a GraphQL endpoint, the query and so on. It generates the types for you internally, and you don't have to do the type annotations, and everything works magically for you. And this is really, really handy, because at all times, this is type safe. And this is magic. That said, it's not always green on the other side. Because if you, let's say, for example, you don't want to accept these 3 parameters separately, but you actually want to have a type species that contains a name, characteristics, and population, then you type it out. And what happens then is, though, like, okay, it could figure out all the typings by itself that it matches, that's fine. But when you use it, type inference, at least in Reason and OCaml, only works, the boundary basically where it stops working is modules. If you then start to use it somewhere, like a specific type, a specific record type that you defined, and it's not in the same module, in this case it wouldn't be, then you have to specify it. Still, this is like one small type annotation, and the rest you get for free. And that's, at least to me, a pretty cool feature. So, the third thing that was my structure is really odd. Why is there let make? You know, here in the beginning, we have let make. This is simply a decision that the team did. That basically, when you have the ReasonReact team did, when you have a ReasonReact component, it expects from you that there is a make export, and this is not. Yeah, this is simply a decision that was made, and that's what it is. But what if we want to use it with JavaScript? We can still do by basically extending it to have a let default and then assign make, because then your ReasonReact component is usable as in ReasonReact JSX, but also in plain React.js. And you can import the compiled JavaScript file and simply use it as your in React.js. All right, let's take it one step further. State. I want to build a small application, like an alien factory, where I have a button and where I can add aliens. Each button click results in like basically concatenate the string that's extended. And the React team did a lot of like investigation and basically tried to figure out a way to like make really comfortable a comfortable developer experience managing state in React components, and that is what hooks are. And obviously, and this is like one of the key features of the new ReasonReact version, it basically tried to match exactly what's there, and so we have used state as well. And in the end, like, it's exactly the same thing. There's no magic on top of it, and if you use the ReasonReact state here, the output doesn't add any runtime overhead. It will be simply plain using React.useState under the hood. So we can, instead of, there's like some small details, instead of an array, you have a tuple, because we have this data structure available in Reason, and it's just a better fit for that. So we can use a tuple, and then we can pass in the initial state. It always has to be a function. In plain React, it can be either a value, a default value, or a function that returns a default value. In Reason, it's just always the function. And yeah, so here you have useState available. And then we can have the onClick and so forth, but I don't want to burden you with that. There's one thing though, that is again, that I find particularly interesting when we talk like one more thing about type inference. If you have this, like in this case, like this is something that TypeScript Flow or so, they could easily do it. Basically on the initial value, they can figure out what's the type and so on and so forth. But if you want to set the initial value to something that is like null, or in Reason it's based off an option which is none. In Reason type inference, like you can set it to none in the beginning, and later on assign an int to it, and it basically will infer cool. Well, you have to use options, so it's kind of explicit anyway, but you define how, like the compiler again can figure out what the type is. But if you want to basically match the same behavior in TypeScript, it can't do it. So you have to manually, and this is exactly the same with Flow. They're like, I'm just using TypeScript here because it's most people are, or more people are aware of it and know the syntax. But type inference is a really, really awesome thing. Writing less types and actually getting the same type safety as if you would write all the types is an amazing experience. All right, let's take it one step further. Because I'm a really, really lazy person, I don't want to hit the button in my factory all the time. So what we want to do is we want to automate this process. Aliens should pop up every 200 milliseconds. What we can do, we can use useEffect. And basically where I want to go here is like every hook that you have available in plain React, you can also use in ReasonReact. And this basically looks like this. We use a set timeout. Don't worry too much about the code. It's just about the idea. And obviously, we also we can have custom hooks. That's completely fine as well. So you can have any custom hook that is out there, type it, create type bindings, and use them as well. And in fact, for the Apollo example in the beginning, you might have not seen this because I was really quickly glancing over it, but it was a custom hook that was simply matching the new React hooks from Apollo and basically typing that and using that under the hood. Yeah. And that's really, really awesome because you can leverage the existing JavaScript ecosystem, just type it, or even build your own hooks, and that's completely fine. So one last thing. What about if you have an existing code base and you really want to adapt Reason? One thing that is really, really mandatory to adoption, and I think this is also one of the key factors why actually React could become so big and so dominant in the industry, is because it was so easy to incrementally adopt it. It was not something that you had to make a full rewrite. You could simply put it into your backbone application, put it into your Angular application or Ember application, and like just let it sit there, and like from inside out, you could simply expand from there. And the same thing, the same idea, I mean, Reason is built by the same people that initially built React. They have this intrinsically, this idea, everything must be, like, it must be easy to adopt step by step. And obviously, today the game is a little bit different because adoption also means like you have to not only integrate into an existing like JavaScript code base, but you must integrate with either like a Flow code base or TypeScript, and everything should be type safe. You want to have this type safe. And therefore they built genType. So how to use genType, or what it does, is you simply edit. You have a little bit of configuration. You say like, I want to target TypeScript. I use this ReasonReact shim, which are just a couple of, a bunch of type shims. And then the component that we had before, just showing the name, characteristics, and population, I simply can extend the default, let default equals make with genType. It's another PPX that does a lot of magic. And what happens then is that you basically get a new file. Suddenly you get a species.gen.tsx file. And if you look into it, it has TypeScript definitions based on what our, like, we know name characteristics, we know the types of name characteristics and population, and because Reason and OCaml is like a tighter type system than TypeScript, we can always map to something that is valid TypeScript or valid Flow. So we can do this, and the best part then is, so if you have an existing TypeScript application or Flow application, you can simply, you basically get, like from a ReasonReact component that you wrote, you can still, like from inside out, use it in your TypeScript application and get the same kind of type safety. And one last thing, what if you have like specified a type, just to give you an idea, you can export it basically to a full type, or you could even, based on a setting, make an interface. So really brief recap. What did we learn and what can we take away? A PPX is basically a superpower. I'm not sure, like, it comes with its trade-offs, because if you write the PPX for one version of an AST, it might not work for the next one, and this is a trade-off that has to be consciously made. But it could be really, really interesting if in our type systems, like TypeScript and Flow, if we get the opportunity to make this magic happen. I'm not sure if the trade-off is worth it, but I wanted to at least show you what's possible. Type inference is like this magical thing where basically the compiler goes deep into your code and understands what type you're actually using here and expecting here, and it does the magic for you. In ReasonReact, we have hooks available. They do exactly the same, and the developer experience is really, the developer ergonomics are really, really handy. And with genType, you can basically incrementally adopt it. I hope this was an interesting exploration, and looking forward to the next talk. Thank you very much.